Hey, everybody, and welcome to Build and Breakthrough. I'm your host, Hunter Harris, and with me today is Elisabeth Hendrickson. She's the CEO of Curious Duck Digital Lab. She's an advisor, speaker, and author of books including Signals and Levers and Explore It. And today I have her coming on to discuss Signals and Levers, which I recently completed a pre-release copy of. Very interesting to read. Very excited to talk about this. Elisabeth, you want to introduce yourself a little bit?
I never know what to say about myself. I think you already covered it. Thank you so much. Hi, I'm so glad to be here.
I'm super happy to have you. I guess then let's kick it off with part of the book that stuck out to me, Project Snowball. No spoilers, just saying Project Snowball, right? So one of the things I love about that specifically is let's start small, starting small, right? So I'm about to just start with an absolutely insane question, but for the audience, I want to ask it. Why start small? Isn't it easier for me to go and just break off a giant piece of work and attack all of it all at once? Like, why don't I just do the thing? What is the advantage of starting small?
Okay. So let's first of all, let me answer your question directly. Why not just do the big thing? I mean, especially in this day and age, we've got all these amazing tools. They can do practically magic
Mm-hmm.
things. Why not just go do the big thing? And the short answer is risk. That if you try to tackle a gigantic thing, regardless of what your tool chain is or what industry you're in, it's if you build a gigantic thing and then go ship it, there are so many unknowns, so many. They just keep accreting. All of the unknowns keep accreting. So way back when I entered this industry, it was very typical that a release for any kind of software was typically like at minimum a year for a big release, and sometimes 3 years or more. As a consultant back in those old days, I was once brought in year, let's see, I think it was, they were entering year 4 of a 3-year project. And they were having trouble shipping. People call me when they're having trouble shipping, and they were having trouble shipping.
Mm-hmm.
And so I got in there, and there were just so many places where they allowed risk to build up without ever getting any kind of feedback loop, any kind of empirical evidence
Mm-hmm.
about the extent to which all of their guesses, the ways in which they were speculating, whether or not that was actually true. And so that's why I never recommend go big or go home. I always recommend small. And that applies to everything. No big transformations, like the gigantic agile rollouts without ever piloting a process change in a given organization with a given context. Also incredibly risky. A gigantic go big or go home product launch.
Mm-hmm.
You don't know if you've met product market fit. You don't have any signals. So that's why not go big. But I also want to unpack what on earth is Project Snowball, because it's a thing that happens in the book, and the specific thing surrounding that, it isn't necessary to know that to appreciate Operation Snowball, what Operation Snowball is. That is taking, both in the book and when I have heard this sort of framing in the real world, it's around things like technical debt, and it's borrowing Dave Ramsey's concept of the snowball method of paying down debt to
Mm-hmm.
technical debt. And I also want to give a shout out to my friend and colleague, Nat Bennett, who coined this term and gets credit in the book for having coined
Mm-hmm.
it when they were the anchor, basically the team lead on a team in Cloud Foundry way back in the day at Pivotal. And they were dealing with a context where it was so target rich for paying down tech debt. And there are so many circumstances in which an organization would say, go big or go home. We're just going to rewrite
Mm-hmm.
it, hit the big red reset button. I've never seen that work.
The classic.
And so
Couldn't be
I
more
know,
popular
right?
today.
100% classic, happens all the time. And Nat's approach was far more pragmatic and leaned heavily on this idea of, instead of trying to pay off the gigantic thing that has the higher interest rate, start with the smallest thing that you can pay off and use that bandwidth you just clawed back to pay down the next thing and the next thing and the next thing. And you get a sense of momentum and satisfaction, and you get to test your hypotheses. And so I think it's important to shout out to Nat Bennett for that one, because it's a great framing for this kind of thing.
Yeah, I thought that was a particular concept that leapt out at me because that, like several things inside of the book, that was kind of putting a name to a thing that I kind of intuitively reached. Like a lot of the concepts talked about in the books are things that I've intuitively reached through experience. And you already transitioned to the next concept that I wanted to talk about, which is kind of like, I felt like it was kind of a theme of the book. And also, I imagine it's a theme of your and my career, but feedback loops, right? So
100%.
getting to more effective and faster feedback loops. So I guess a jumping off point for this, you mentioned, for example, like starting with batch size, work in progress, and feedback latency. Let's just start with like batch size. Like if I, as an engineering leader, wanted to start investigating feedback loops related to batch size, how do I start there? Why do I start there? All that.
Totally. And here, let me just check in on when you talk about feedback loops and batch size, immediately what I hear is feedback latency. So, because the bigger the thing is, the longer it took to create, the longer it's going to take to get through whatever feedback loops we have. And therefore, from the moment that I started setting my intention to the time that I actually have some kind of empirical evidence about the extent to which I did what I intended to do and nothing I did not intend to do or that would cause harm, that latency becomes so huge. So that feedback latency, that is what allows that speculation to build up. When I talked before about the speculation, we're making guesses and assumptions, we're speculating. I call that speculation buildup, and you can visualize it almost like a ramp. It's a curve of some kind. Maybe there's a lot of speculation early on about even what market we're approaching. And then there's speculation about whether or not we did what we intended to do and whether or not what we did will work in production, because production will be different, and whether or not users will be able to use it because users will do wild and crazy things you never would have anticipated.
Very much
Right?
so.
All of those ands. That creates this curve where at some point you start getting empirical evidence about the extent to which
Hmm.
all of the things you speculated about are in fact real, because you've been forming these hypotheses even if you weren't explicit about it. All of the area under that curve is risk. And so when we
Hmm.
look at batch size and feedback cycles, and people talk about how important it is to have fast feedback cycles, from my point of view, ultimately what we're doing is reducing the area under the curve, reducing the amount of risk so that we can steer towards the value rather than make a gigantic bet, like take the entire of the value of the farm and put it all on the roulette table all at the
Hmm.
same time and just hope that we will have succeeded. Instead, I want to operate more from the perspective of getting a little bit of information, a little bit of information, a little bit of information, and use that information to steer in the direction that I'm aiming for with whatever the thing is that I am building or designing or whatever.
Yeah, so to kind of extend the metaphor of steering, I think probably everyone that's listening to this has probably driven a car, or at least some sort of motorized vehicle at some point. Imagine if you could only turn the steering wheel once every 5 minutes. That would probably be a bad situation. You might not want to get on the highway. But taking that turn the wheel every 5 minutes down to 1 minute is already a significant change, but still incredibly risky. Now let's turn that down to 5 seconds. Another huge, gigantic change in how quickly you're receiving feedback, but still, that is 5 seconds on the highway. You may be able to drive on local roads, maybe, but you certainly can't drive on the highway with that level of feedback mechanism. So it's all about bringing your hypothesizing and the results of your hypothesizing into the present as close as possible so that you can make whatever targeted adjustments that you need to make, right?
Yeah, and I love your metaphor, like your extension on that metaphor, because part of what you're pointing out is that the context in which you're operating is going to have a lot to do with how fast your feedback cycles need to go. So, hypothetically, let's say that you are operating one of those incredibly slow little kiddie cars and you're doing it on a gigantic, like, field with zero hazards and no other traffic, and you put on a blindfold and every 5 seconds you're allowed to peek. What's the worst thing that could possibly happen? You end up like kind of bumping against whatever the guard fence thing was, right, not a problem, you're fine. But you start operating it a little faster and you could hit that fence post a lot harder. Now it's a little bit more dangerous. You take that out onto a space where maybe it's not even dangerous other traffic, but it's other traffic. There are
There's other
pedestrians or
vehicles.
whatever. and it becomes that much more dangerous. But so many organizations that I see have feedback latency that's measured in weeks to, in some of the really scary cases, months. But they're trying to operate a business that is playing in the same field as the businesses that are deploying daily with feedback cycles measured in hours. And they're really going to struggle. It becomes really dangerous. And especially now you add in security as an issue as well. Like if their ability to adapt is so slow that they can't respond quickly to security threats, it becomes even more dangerous. So yes,
And
100%.
one of the interesting things, talking about this particular level of scale too, that I want to note for all the listeners is, like, since the topic of systems thinking is a recurring thing on this particular podcast, we're discussing a business, which is one entity with, and we've discussed like one particular feedback loop for that entity. But that feedback loop is made up of feedback loops, for example, in product and engineering and QA, in customer success and support. And then each of those feedback loops is also made up of feedback loops, which is inside of engineering. You may have your engineering feedback loop inside of the overall SDLC process. And then inside of that, you've got individual feedback loops, such as your individual feedback loops in terms of, and I forget if the learning flywheel was specifically in the individual sense. I think it was in the organizational sense.
Yes.
But I mean, even that organizational learning flywheel has component individual, like, and then when you get to people, like there's feedback loops just in terms of your biology too. But now we're getting to a scale that's probably less interesting for the overall viewership, although I enjoy that. But like when you are dealing with an organization, when there's so many interconnected feedback loops, how do you dig in to, like, how do you go about RCAing when you see like a high level issue? How do you zoom down through the various feedback loops to the appropriate level of fidelity, or potentially zoom up when the issues end up occurring due to external feedback loops?
Totally. So there was so much in there. I just want to focus on, since you said RCA, root cause analysis. How do you figure
Yes.
out what's actually going on? And one of the key things about systems is that there is never going to be a single smoking gun. And so that's one of the first things that I want leaders to know, is that looking for the person whose fault it is never going to get you where you want to go, or the department or the process or the function or the one mistake that led to all. That's kind of not how systems work. Instead, the outcome that you're getting is because of this web of influences within the system. So let's say hypothetically, well, why don't you tell me, like, what is a problem that we would want to like dig into to understand better? I don't care what we do. Pick one.
I think a pretty classic one that I've had a couple people talking to me about recently is, okay, we recently put in AI, and now everything's backing up in QA, and also we're shipping more defects. So why is our QA team evil and bad?
Right. This one hits home.
I know, right? My heart. If you're listening, you know who you are. I'm so sorry. It sucks.
Well, and also you're not alone, because you and I,
Yeah.
we have not been working for the same clients, and I'm hearing similar things. So like,
I'm sure.
Right. This is definitely, it just hits particularly close to home because I have spent so many years with the word quality somewhere in my title. And as I have said to others, I did run away from that for good reasons. And that was long before AI was a thing. Okay, but let's come back to, so somebody somewhere wants to know why QA is evil and bad, and why aren't they doing their jobs? Because we just did this amazingly cool thing. We brought in AI to make everything better, and now things are slower because QA is so slow and they're not catching the problems. What's wrong in QA? That is a great classic example. So let's look at what's actually happening. I'm imagining that in this hypothetical situation, we're using AI to generate codes. So now we're able to have a developer can go from doing, a couple of pull requests a week to like multiple per day with the help of their friend, pick your favorite flavor, but Claude or Cursor or whatever they're using. Or maybe they're super adventurous and they're orchestrating entire fleets of agents, but whatever it is that they're doing, they can now generate code so fast.
Exactly. Engineers are now utilizing, let's assume Claude.
It doesn't actually matter which of the tools.
Very true, too.
Yeah, the tool is not the
But let's
fault.
say Claude engineers are, well, this will sound very familiar too. Engineers, they've adopted AI. AI allows them to go faster, and as a result, they are not QAing what they're doing because they don't have enough time to do that. They need to be shipping more stuff with AI.
Right. They need to be more shipping more stuff. That is a key thing right there. So okay, so the first thing is that it's very tempting to find the one thing to blame, whether that's QA or we must have bought the wrong tools or the developers have gotten lazy. None of that is actually going to be accurate or help.
Mm-hmm.
And so then what you just said though is a great example of a system effect. The developers are feeling pressure because the expectation for the number of pull requests that they're going to be submitting, or whatever they call it, change sets that they're going to submit, that expectation has now gotten higher.
Mm-hmm.
And so they've got this thing for themselves inside their head, which you don't need to diagnose. Like this is a classic example for those of you who do object-oriented software development. The stuff that happens between the ears is a private method. Stop trying to call it. It doesn't matter why but the fact is the system is rewarding speed over due diligence, over care, over testing potentially. And then
I think so.
One of the things that happens when you introduce a new tool that's going to radically increase the amount of code that somebody can generate, there was a whole system, a whole value chain in place to go from concept all the way through production. And in many organizations, there's going to be a bottleneck. Well, let me back up, and then I'm going to justify the use of that word. There's going to be a series of quality gates at the end. Usually managed by somebody in a QA or a set of people in a QA role. Now, the particular structure is not as common anymore as it used to be, like the standard with the whole set of best practices around that, et cetera. But let's say you're in an organization where from idea through production, there is some defining of the intent of what we're going to do, some prioritizing, some code generation happens, whether human or otherwise. Then there's a series of quality gates that include CI/CD, that includes automated testing, and that includes some kind of, yay, verily, the QA people say this can go. And then there's some kind of operations review or something, and then it goes out to production. That system might have been operating in steady state with the old way of working. And now we've radically increased the volume in the code generation side. So there's this book called The Goal that Eli Goldratt wrote. I could grab it off my bookshelf and tell you what year, but it was many years ago at this point. The book itself has not aged particularly well, but in it, it describes this effect of the bottlenecks, which is why I referred to this thing as bottleneck at the end. The system as a whole can only go as fast as the constraint. So if your system was in steady state, everything was balanced over a period of probably years and years and years, so that the capacity, the input, ingest capacity, and output was neatly balanced across all of these stages. So now all of a sudden, you've introduced a change. We can generate more here. The rest of the system didn't compensate. The system still can only go as fast as the constraint, which is often in QA, especially in organizations that don't have good coverage from automated tests. So that's why you're seeing the results that you're seeing as an organization where now QA can't keep up, because QA was always the constraint in the system. It's just the system was balanced enough that you didn't actually notice it before. I'm seeing comments about, oh, the bottleneck moved. The bottleneck probably didn't actually move.
Always has been, kind of.
Right. The bottleneck was actually never the code generation.
Never. I've never worked for it. I've worked for organizations where literally I was all of the coding capacity, and code gen has never been the bottleneck in any of them.
Right.
I actually want to, on the note of feedback loops and bottlenecks, want to dig into one interesting thing that I've seen in this sort of situation here. So we're talking about an organization that has a pre-existing bottleneck, but one of the interesting things that I've seen in these sorts of situations is the bottleneck can actually get constrained. Like the bottleneck becomes bottleneckier when you add too much capacity in advance. Because specifically to your point about quality gates. The terminology I like to use these days is not necessarily like QA professionals, but people embodying quality responsibilities. So in many cases, that's additional developers, that's a QA person, or in a lot of organizations, it's a product person, or sometimes multiple product people. Usually there's a constellation of these individuals. One thing that's very interesting that I see is a combination of back pressure and siphon pressure. So these product people, they exist on both sides. So they're defining the requirements, they're defining what good is, and then they're required to go into the system at the end and validate that what they've established is actually the same thing on both ends. So now you have a system where in the middle, things move very quickly, which creates back pressure in the quality area, which in turn creates siphon pressure in the pre area, the area before that section. So what can occur is the siphon pressure pulls the product people into the weeds, essentially. They also have to get involved shipping stuff just to feed into the engineering unconstrained section, which in turn increases pressure on the bottleneck while also decreasing its throughput, because the same people that should be moving into alleviating the bottleneck are being pulled away from it into this area where essentially everything is moving as rapidly as possible.
Mm-hmm. No, that's a really good point. But the one thing that I want to check in with you on, because what I'm hearing you say is that when you've got a product person who is both specifying the what we're going to build and then also accepting that they got what they asked for, and the they have to feed the beast in the middle, and this group runs out of stuff to do, and so now there's pressure on them to go back and spend more of their time defining what we're going to build. But in the meantime, everything is backing up on the last step in the process, so we're not actually successfully shipping. That's what I'm hearing you say.
There's other aspects there too. Like generally, first of all, they're specifically cutting tickets to feed the beast, as opposed to doing higher level strategic work. And for example, having engineers do the work of just like brute cutting the tickets, for example. It has a really interesting compound effect of pulling product people from a strategic layer into a tactical layer. And especially with AI, they're also incentivized in many organizations to actually go and participate in shipping code as well, which then further turns this particular vicious cycle, right? So there's a number of aspects there. Realistically, it's actually pretty easy to prevent that. All you have to do as a product manager is say no. But most organizations don't really reward those words.
I was just going to say, all you have to do is say no. Do you have any idea? Like, for a 2-letter word, that is like the hardest word in the world for people to say.
Yes, it is important to discriminate between it is a simple solution that is not necessarily easy to implement on a socio-emotional level.
Yes, exactly. But one of the things that I thought I heard you say that I wanted to check in and make sure I understood was that trying to get ahead and expand the capacity of where you think a constraint within the system lies can actually make the constraint, well, I loved your framing, more bottleneckier. Did I mishear you? Is that what you were?
I believe I said that. In general, if you just go into a system or like go into a factory and just be like, we're going to open this thing up, that generally doesn't necessarily have positive effects. Bull in the China shop. I speak from the heart because I've been this person making ill-advised changes a few times in my career. And I've come to the realization that like it's not about speed. If you want to have speed, and there is some value there, not by itself. But if you want speed, it's more about balance between all of the pieces of the system than really just turning the crank on any one thing. It's very easy for individuals, especially IC individuals, to be like, hey, if I do my job harder, that's good, right? I get rewarded for X, so if we 2X or 5X or 10X, more is better, right? But unfortunately, in the real world, that's not quite how it works, right? And so like a big thing that I tell a lot of developers is like, adopt AI, but also work right to left. So it's to your point about feedback loops and works in progress, right? Have less work in progress, complete more, start less. To the point of quality gates, get in there, like assist with other people instead of being fully unconstrained on this part that is very fun, It may feel rewarding. If you run your company that way, you will be outcompeted by competitors that are better optimized and can actually get things done to serve their customers. Essentially, it's a lesson of like, if I optimize for my micro environment, that does not necessarily extrapolate to gains for my macro environment, right? Like all the engineers doing engineering as hard as possible is kind of the definition of a local maxima, where for your organization, it's probably not an especially effective situation.
I love this because you're describing so many of the system effects. So let's start with inherently software development. No matter how you slice it, software development is a nonlinear, adaptive, socio-technical system.
Mm-hmm.
And that sounds like a mouthful, but what it boils down to is you can't reason about it with simple cause and effect. And it is so tempting.
Mm-hmm.
You and me both, with having been the bull in the china shop and making ill-advised decisions. You and me both, because it is so tempting. It looks like the problem is X. So I'm going to look at X and say, okay, what is the linear connection XY? Okay, I'm going to go pull the lever over here that I think is connected to X. Very linear thinking. The nearest lever, exactly. And it is also sometimes very tempting to pull the nearest lever, even if you don't think it's connected directly to X, because it's the easiest one to pull.
Ooh, that's bad.
Yeah, that's bad. That is a whole other thing. That's not actually what you were describing. But the idea is you pull a lever and you expect that you pull the lever, you get the gumball out. It's a simple linear system, right? It is not. It is not at all. You poke the system is gonna poke back. So as soon as you make a decision as an organization, for example, that the product managers are going to both request what they want and be the ones to say whether or not they got it, which, by the way, I wholeheartedly endorse.
Mm-hmm.
I think this is a great practice. Doesn't mean that I don't value people who think about and study testing, but the idea that it is a product manager who ultimately accepts that they got what they asked for, I think is a really important way to make sure that they actually are involved in the decision to then go forward and not running untethered open loop at the beginning of a cycle with neither responsibility nor ability to affect the outcome. So I'm totally on board with this.
Throw it over the wall, right?
Right, exactly. Which, we've, I think, all seen too many organizations where at each stage it's just like it's treated like a relay race.
You're smart. Go off into the distance and execute.
You figure it out, right?
Yeah, you're a smart guy.
Right. Okay, so we make this change without thinking about how you poke the system's going to poke back. Mm-hmm. What are not only the things that we want to be true from this change, but also what are possible unintended consequences, and how do we pay attention to those? So then you start noticing, oh, okay, well, we're seeing these weird system effects. And instead of panicking about them, just like, oh, okay, well, that's really interesting. Now what we're seeing is that there's actually this kind of doom loop thing happening. I'm imagining an organization similar to what you described, where the product managers are specifying the thing up front, the engineers are delivering, the product managers are accepting, only the product managers never get time to accept because the engineers keep putting pressure on them to produce more tickets to feed the beast, right?
Right.
Okay, so now we're in this like downward spiral where all this work we've got inventory that's built up and we can't actually recognize the value for that inventory. We can't ship. So that's by acknowledging, instead of fighting it and saying, oh, well, those product managers are being bad, they should feel bad, they're doing bad. And instead just look at it like a system. We can say, okay, well, what would fix this? We can't know. We can only have hypotheses, and the system's still going to poke back. But one intervention is to limit the amount of unreleased stuff, which is basically a way of limiting work in progress. When the threshold gets too high, then to have a working agreement that I don't care how hungry you are for new tickets, go work on something else because we're going to be over here making sure that the software can actually be released. Or by hypothetically saying we have a working agreement that my number one priority every day is if something is ready for acceptance, I'm going to do acceptance first. Then I will turn my attention to other things. And if I spend 100% of my time doing acceptance, eventually I will run out of things to accept. Because they will have run out of tickets to implement, right? So it requires there is no one root cause that anybody could point to. There's a system of effects. And the way that you navigate that is by being willing to actually look at the system without blame and then start reasoning about the what would make it better in the future, not what caused it in the past, and then forming hypotheses and then testing those hypotheses. Hence tight feedback cycles on process changes, which is the other thing I love about your hypothetical story, is that somebody speculated, because again, this is a speculation buildup, speculated
Of
that by
course.
making this big process change, it's going to make everything better, and then just said, go forth and do it, with no attention to the feedback cycles.
Rip off the Band-Aid, go for it, right?
Right. Without attending to the feedback cycles. Feedback cycles are for everything, not just product. It's also for process, for working agreements, for feedback on
Relationships
everything.
between departments outside of engineering, right? Like
100%.
quintessentially, like there's a feedback loop between sales and engineering, right? Like
Yeah.
sales depends on engineering, or I shouldn't say just engineering, but your product technology organization. Like that's kind of the quintessential engine that runs the company, right? Product technology builds a thing, sales sells it, gets feedback, feeds that back into product technology to build the better, newer thing to sell more hardware.
We are all interdependent. And that gets at something
Yeah.
else that you said. You were talking about feedback cycles within feedback cycles within feedback cycles. And I tend to think of it more like systems within systems. So let's say
That's
you work
true.
for the product technology group. That group is a system, but it exists in the larger system, which might be for a large company, a division or a business unit. But for a smaller company, it might be the company as a whole. Regardless, that company or that division might live within a company. The company itself lives within an ecosystem. The ecosystem lives within an economy. You can't get away from systems. It is like
Absolutely.
the universe is turtles all the way down. It's systems
Systems
all the
all the way
way
down.
up and down the chain. And all of those systems are nonlinear, adaptive, socio-technical or socio systems. And ultimately, that means that people are at the core of everything. I don't care how much
Yep.
AI you rub on it, it's still people, and it's always a people problem. It's never actually, technical problems are simple, they're comparatively easy to
Yeah, the
solve.
computer just does what you tell it to. Like
Or
that's
not if
I
it's
think
an
that's
LLM, but
probably
you know.
well, yeah. I mean, up until recently, but that's kind of been the appeal of the tech field for years, right? Like I got into this in part because I learned human languages like Japanese and Korean first before learning like software languages, and I found explaining things to computers a lot easier than explaining things to a fellow human because it does exactly what you tell it to. And if it doesn't do what you tell it to, it's not because of the computer, some exceptions, cosmic radiation and all that, right? It's generally because you've explained it wrong. And having the humility to go and learn to explain things better, and I think to kind of like put a bow on some of these concepts too, the humility to recognize that you are part of a greater system, and kind of the courage also to say that your individual actions can contribute to and improve systems around you is a very important perspective to have. Without that perspective, I've found a lot of people that are like, I'm in a system, I can't do anything, so I'm just gonna like be a little bit antisocial and whatever. No, you're making the system be that way yourself. So get out there and like be the change you want to see in the world.
Feed what you want to grow. You are part of the system. You're in the soup. You can't escape it, even by trying to escape it. So sorry, everybody. We're all
Yeah,
interdependent on one another as much as you might not want to be. That's just how everything works.
yeah. Well, Elizabeth, I want to be respectful of your time. This has been fantastic. We kind of talked around the book, actually. We didn't like talk directly into the book. So, do you want to plug the book a little bit?
Sure. So my co-author and I, Joel Tosi, just finished, like very recently finished, Signals and Levers, Systems Thinking Tools for Unblocking Software Delivery. It's coming out from IT Revolution in September 2020. We're so beyond stoked because we did manage to capture in the space of this book a whole lot of stuff that we also didn't have names for, but like you, had intuitively understood. And we took a lot of kind of mental wrestling together, the two of us, to get it all into packaged in a linear way to help other
Mm-hmm.
people understand it. So that's what we've been discussing. And I'm so grateful for the opportunity to have this conversation with you.
I'm super grateful too, and thanks for letting me read the book early. It was a very interesting read. We didn't get into any of the spoiler territory for any of the characters, but it was very interesting to see some of the character arcs described there. Man, it was a very interesting read. It was amazing how it really resonated with a lot of my experiences overall. And I mean, it's not out yet. We're going to put links to where people can pre-order it, but I really recommend that people check it out. I hope you enjoy it as much as I did. And for everybody listening, I hope you've enjoyed it. Check out those links. And I hope you all have a fantastic day. Peace.
Thank you so much.